Hello guys, I have prepared some basic multiple choice questions which you must know to have an understanding of sequential circuits. So few multiple choice questions about sequential circuit. So this is one question. Sequential circuits differ from combinational circuits in the context of option is output dependency, B is clock requirement, C feedback or memory, and D is all of the above. So you have to think which option is right. So first of all, try to solve by yourself. Then in next slide, the answer is there. So you can find your answer and you can cross check your answer is also. So all of the above is the right answer for this question. The second question is a basic SR latch can be constructed by cross coupling of which type of logic gates? So the option A is about basic logic gates, not or and. Second option about logic gates, universal logic gates, nor and and. And third option about special purpose logic gates, that is XOR and XNOR. So you have to think by using which type of logic gates you can construct your SR latch. So the option B is right for this question, universal logic gates. Cross coupling of NOR gate and cross coupling of NAND gate, we are able to construct SR latch. The third question is, if SR set and reset both input are 1 1 for NOR latch and both input are 0 0 for NAND latch, then which common output status made by these two latches? So first of all, try to think about first one. If both input are 1 1 for NOR latch and if any of the input is 1, then output input S is 1, R is 1. You have both output as 1 1. But for latch, output should be complementary. So it is like showing some invalid or forbidden state. You can cross check also the same thing for NAND latch. If S is 0, R is 0. So what is the property of NAND latch? If any of the input is 0, the output is 1. So in this case also we are getting the same output for both end, whether it is normal output or complemented output. So both are representing like invalid and forbidden state. And this one is the right answer for this question. Read this fourth question. The truth table of an SR flip-flop has how many valid or defined output states? So for SR flip-flop, we have one condition for no change, one condition for set, one condition for reset, and one condition is forbidden state or invalid state. But the question is about how many valid state. So this is clear. Out of 4, we have only 3 valid states. So 3 is the right answer for this question. And this one is right. Read this fifth question. Which option is true about the main disadvantage of SR and JK flip-flop? So we have to think clearly what is the drawback of SR flip-flop and what is the drawback of JK flip-flop. So you must choose the right combination in option A, B, C and D. So let's see what is the right combination for this question. So the option B is right. In SR flip-flop, invalid or forbidden state is the drawback or disadvantage, and race around condition is the disadvantage of JK flip-flop. The sixth question, which characteristic equation is correct regarding basic flip-flops? So in option A, the characteristic equation of D flip-flop is given. In B, characteristic equation of JK flip-flop is given. In C, characteristic equation of T flip-flop is given. So if you think all these 3 are right, then option D is correct. Or If two are wrong, then only one should be correct. So let's see what is the answer for this question. The answer for this question is all of the above, means all character equations are right about D flip flop, JK flip flop, and T flip flop. This question, in context of flip flops conversion, which set of equations is correct? Okay. So the option A is S equal to D and R is equal to D bar. Option B is J is equal to T, K is equal to T. So you have to check all these options and try to think which options you find is right. Let's see which option is right here. See both. If we connect S and R using one NOT gate and the simple input given to the S and complemented input is given to the R, then we get D flip flop from SR flip flop. And if we sort J and K terminals, flip flop from J and K. Question number 8 about if the input frequency is F to a cascaded ripple counter composed of mod M and bit mod B, then what will be the output frequency? So first of all, pay attention to this thing. The first cascaded counter is mod M. The second one is N bit. And the you have to calculate the mod of this counter. If N bit counter is there, if N bit ripple counter is there, then what is the mod? What should be the output frequency for this cascaded one? The frequency divided by the multiplication of mode of individual counters. So the first counter is mod M, second counter is N bit. So the mod for this counter is 2 to the power N and mod P. So I think option T is right about this. Yes, option D is right for this question. And you have to pay attention for this. Somewhere mod is given and somewhere N bit is given. So you have to calculate the mod if counter is specified by the bits. So let's take one example here. What will be the output frequency of cascade ripple counters? The first cascade is mod 2, mod 4, mod 6. So in this case, all three counters are specified by the mod number. So we have to multiply and divide the input frequency F. And the second cascade is given for 2 bit, mod 4, 3 bit. So 2 bit means mod 4 and the second one is also mod 4 and 3 bit means 2 to the power 3. So it is mod 8. So you have to calculate the output frequency based on the formula frequency divided by mod of first counter into mod of second counter into mod of third counter. So let's see which option is right for this. Yes, option D is right for this one. So what is the advantage of Johnson counter over ring counter? So the first option is the output of last flip flop connected to the input of first flip flop. So in first option, this is not specified which output of last flip flop, means whether it is normal or whether it is complementary connected to the input of first flip flop. The second one, it generates half output frequency compared to ring counter for the same number of flip flops. Okay. The third option is it utilizes twice number of states compared to ring counter for the same number of flip flop. So the question is asked for advantage and option C is reflected the advantage. It utilizes twice number of states compared to the ring counter. So I think option C is right for this question number 10. Yes, option C is right. Let's see what is the next question. Yes, question number 11 is how many used states possible for N-bit ring counter and Johnson counter? So if you remember about ring counter, Johnson counter, then in ring counter, number of used state is equal to number of flip flops. So this is n bit ring counter means you are using n flip flop. So it is n. And for Johnson counter, because Johnson counter utilizes twice of states in comparison to ring counter. So it must be 2n because n bit is the same for ring counter and Johnson counter. So I think n 2n. No. So option A should be right for this. Yes, option A is right for this 11th question. The next question is required clock pulses for data in and data out for n bit SISO and SIPO shift registers. Then you require n clock pulses for serial in data, or you require n minus 1 clock pulses for serial out data. And in this continuation for parallel in, you require 1 clock pulse, and parallel out can be taken out data without using any clock pulse. So based on this serial in, serial out, parallel in, parallel out, you have to think which combination is right for your question. Means required clock pulses for data in and data out for n bit SISO, SIPO. So for serial in we require n clock pulses, and for serial out we require n minus 1 clock pulses. So n comma n minus 1. Okay. So this one is given in option A, and SIPO for serial in n and parallel out 0. So option A is right, and you have to remember all required clock pulses for serial in, serial out, parallel in, parallel out. So the option A is correct for this question. The required clock pulses for data in and data out for n bit PISO and PIPO shift register. Okay. So PISO means parallel in, serial out. For parallel in, we require 1 clock pulse, and for serial out n minus 1. So 1 comma n minus 1. So 1 comma n minus 1 for PISO. It will match it with option C. And let's cross check for PIPO. So parallel in require 1 clock pulse, parallel out requires no clock pulse. So it is 1 0. So option C is right for this question. Means required clock pulses for data in and data out for n bit PISO and PIPO shift registers. So option C is right for this one. Yes, option C is right for this question. What which operations in shift registers actually don't require any shifting? Okay. So if you think for serial in you require shifting, for serial out you require shifting, parallel in no shifting is required, just 1 clock pulse required to insert the data, not shifting required. And also parallel out data can be taken parallelly without using any clock pulse. So means no scene of shifting is here. So which operation in shift register actually don't require any shifting? So parallel in and parallel out, both operations don't require any shifting. So I think option B is right. B is right for this one. Yes, option B is right for this one. So we can say parallel in, parallel out means PIPO is not actually a shift register, although it is one of the shift register, but no shifting operation happens in PIPO. The circuit which can be treated for each type of shift registers. Okay. So we have basically 4 types of shift register: SISO, SIPO, PISO, PIPO. The option 1 is serial adder. Okay, so serial adder. The option B is left and right shift register, universal shift register, none of the above. So serial adder option is not right because we are searching for the a circuit that can be treated for shift registers. So option is not right. Left and right shift. Okay, left and right shift is possible in serial in, serial out. But as per the name, universal shift register, the circuit which can be treated for each type of shift registers. So universal shift register is the right answer for this question. Let's see. Yes. Option C is right. Universal shift registers can be treated for each type of shift register, either SISO, SIPO, PASO or PIPO. Okay, so we can also correlate few question, theory important question under the sequence circuit. Everybody should know about flip-flop conversions. So for example, you can try the conversion for from SR to D or SR to T flip-flop. Similarly, JK to D flip-flop and JK to T flip-flop. And designing of ripple counter and ripple down counter you should know about. For ripple counter, you must know the clocks. You have two type of clocks, primary clock and secondary clock. Primary clock is derived from the clock signal and secondary clock is derived from the output of previous stage flip-flop. So you should know all about this question like design mod 8 ripple up and ripple down counter and designing some synchronous counter like ring counter and universal counter. And you should also know about shift registers. So all shift registers are very basics. So you can prepare for this type of question for your university exam and for other test or assignments. Okay, thank you very much.